Good morning and welcome. Happy Easter. Today we're going to be looking at probability of a deck of cards. So we're going to be looking at decks of cards and their probabilities. So let's get into it. So I would like to know what the probability of drawing a queen of hearts out of a deck of cards. I'm going to slip that in there. And I'm going to shuffle it up. And what is the probability that if I were to draw a card from a deck of 52, that I would draw the Queen of Hearts? So, before we can answer this question fully, we need to know a little bit about cards. So, I like to cover all the different things that we can talk about with a deck of cards. So the first thing is, how many suits are there in a deck of cards? Well, there are hearts in a deck of cards, diamonds, clubs, and spades. So there are 4 suits in a standard deck of cards. So it's nice to know that, and hopefully most of you know this, but I know that I've been teaching this for many years, and there's always somebody that doesn't know about decks of cards, so that's why we're covering this. You can also notice that hearts and diamonds are red, whereas clubs and spades are always black. So that's nice to know. How many hearts are there, you might ask? Well, there are actually a total of 13 hearts in a deck of cards. So there are 13. And there are 13 diamonds, and there are 13 clubs, and there are 13 spades in a deck of cards. And that can come in handy when trying to figure out probabilities. So, just looking at the hearts here, we have a total of 13 hearts. So the next thing that's nice to note is face cards. Face cards are talked about a lot, so it's nice to know your face cards. So each suit has 3 face cards: a jack, a queen, and a king. So there's a jack, queen, and king of hearts, of spades, of diamonds, and of clubs. Then we've got number cards. The number cards go from 2 to 10. And then the last one is an ace. The ace is oftentimes considered either a 1 or it can be the greatest card. So it's usually allowed to be greater than a king or lower than a 2. So usually how we look at it is 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and then ace. Ace being the high, but you can use it as the low card in a lot of games as well. So if you count up the total number of cards, in one suit. There's 13, there's 4 suits, and so our total number of cards is 52. 52 cards in a deck. So what is the probability, if I were to shuffle this deck, what is the probability that I would draw a queen of hearts out of the deck? Drawing a queen of hearts. And nope, I didn't do it. But if I did it enough times, if I shuffled the deck of cards enough times, how many times would I have to do it before I would probably have it happen? And if we remember, our probability is the total number of times that we would succeed divided by the total number of times that we could, all the different possibilities. So there's only one queen of hearts, and there is a deck of 52. So there you go. 1 out of 52 is the probability that we would draw a queen of hearts. Now what if I was to do a little bit differently here and just figure out what the probability was of drawing any queen? Any queen. So here I've shuffled them up again. What is the probability that when flipping over a card I would just get a queen? And in this case I did not get it. Any queen. Well, remember there are 4 suits here: hearts, diamonds, clubs, and spades. And there's 1 queen for each suit. So that's 4. 4 different possible outcomes that would be favorable out of a total of 52 possibilities. So our probability is 4 out of 52 that we would draw any queen. And that is a reducible number. We can simplify. Oftentimes if we're doing a compound probability with lots of different things going on, we'll leave it as 4 over 52 because we'll probably have other probabilities that perhaps we have to add together that would also be out of 52, so that would just make it a common denominator. So we wouldn't reduce till the end, but since we're doing this simple probability here, we can reduce. And so I will just do half of 4 is 2, and half of 52 is 26. And then I can simplify it a little bit further here. And half of 2 is 1, and half of 26 is 13. Well, that's interesting because we just talked about the fact that each suit has 13 cards in it. So 1 out of every 13 cards, or 1 out of every 13 tries, we would probably get any queen. So our probability increased 4-fold from going from a specific card to any queen or any king or any specific type of card, but not a specific suit. Let's go ahead and look at the probability of drawing any heart. Any heart. So, our probability is going to go up even more. Because remember, how many hearts do we have? And you probably remember we said there are 13 hearts in a deck of cards. And the total possibilities is 52. There's 52 cards in the deck. So what is the probability of drawing a heart, any heart, out of a deck of cards? Let's go ahead and see if we can get this to happen. Looks like our probability is much higher. Oh, didn't do it. Got a club. All right. Well, 13 and 52 both have 13 in common. So we can reduce 13 divided by 13 is 1, and 52 divided by 13 is 4. So 1/4 of the time, I'm going to draw a heart out of a deck of 52. So that's pretty interesting. Our probabilities are getting higher and higher right now. As we become more general in what we want to have happen, the more likely it is to happen. The more specific, or the more we focus on a specific card, the less likely our probability will be that we'll get it. So so what we're going to do in the next video is we're going to be looking at, if we had 4 cards already known to us, what is the probability that we would draw, say, another 3? So in the next video we will discover how to figure out a much more complex probability. Alright, thank you. And we do have an assignment attached to this video. Thank you.